Hello everyone, this is lab 2 in core practicals for edexcel WB11 biology. Now in this lab the goal is to find the concentration of vitamin C in 3 different juices, J1, J2 and J3. In order to do that, basically we need to start with making a range of concentration of ascorbic acid. Now if you don't know ascorbic acid and vitamin C, or vitamin C has the same chemical formula as the ascorbic acid, so we can make a range of concentration of ascorbic acid. Now in this lab you are provided with a stock solution of 1% ascorbic acid, 1%, and you need now to make different concentration by using the simple dilution. As you can see on the board, making simple dilution by following the formula C1V1 equals C2V2. Now, if you are required to make 10 milliliter, if you are required to make 10 milliliter as a final volume, then you can follow the following formula in order to make the different concentration. So the concentration 0.75 can be made by taking 7.5 milliliter from the stock solution, which is the 1%, and simply adding it to an empty beaker, and after that you add 2.5 milliliter of water into the same beaker. You can look at this table and you can see how the different concentration can be made. After you make the different concentration of ascorbic acid, simply you're gonna make a titration for a specific volume of DCPEP. Now if you get 8 test tubes, and you fill those 8 test tubes with a specific volume and concentration of DCPEP, you can titrate them, or you can add the different concentration of vitamin C at the top of them, and after that you measure the volume needed of every concentration to change the color from blue to colorless. Okay, and then you can repeat the same thing for the 3 different juices. If you do that, you will end up with the table of results. This table of results on the left side, which is the independent variable, it shows the ascorbic acid concentration, the one that you prepared, and the stock solution. So 1 is the stock, and 7.5, 0.50, 0.25, 0.125 are basically the different concentrations that you had made. And juice 1, juice 2, juice 3, and basically what was the volume needed in order to change the color of DCPEP from blue to colorless. Now it is the time for our students to see how would the color change after they do titration. Now here is a test tube. You can drop, you make it 1 by 1. No, this is wrong. You need to add 1 drop by 1. You don't need to add more than needed. This is a source of error. You need to think about it. So here is a DCPIP in a test tube. There is a specific concentration of DCPEP. 1 centimeter cubed only in a test tube, and in the syringe there is a specific volume of what concentration you are using, Mustafa?
0.125.
0.125. Now this is the least concentration of the concentration that you have made. So what do you think?
It's taking a long time.
It's gonna take large amount of volume. It's not about time. It's gonna take the largest volume compared to other concentration. This is correct. Now as you can see, guys, the colors start to change. You can add more. The color should go from blue to colorless, but because we have kind of unstable DCPEP, it's gonna change to brown, and we can use it as an end point. We can use it as an end point to judge the color change. Okay, keep adding drop by drop, and you keep shaking. So if you keep shaking the test tube, you're gonna make sure that the vitamin C would be distributed homogeneously, and adding 1 by 1 drops is helping you to determine the exact volume of vitamin C needed. You keep adding and tell me what is the volume needed. Okay, did you try any concentrations? Not yet. Okay, did you try any concentration? Okay, so this is, for example, okay, this is the 1%. You added DCPEP first, 1 centimeter cubed, and you keep adding 1%. How many milliliters How many milliliters was used to change the color?
0.5.
0.5. Okay. What about the second concentration? 0.75.
1 millimeter.
1 milliliter. So 0.5, 1 milliliter. What about the third one?
1.75.
1.75.
3 meter.
3 milliliters. Okay. It shows the correct trend, because as you can see, the least or the less the vitamin C concentration, the more it requires to decolorize the CPEP. Right? Perfect. طيب. Now you write down your results, Amr, and then you do it for the 3 types of juices, J1, J2, and J3, and after that we can tell the concentration about the concentration of vitamin C in every one of those juices. Okay, now according to the results, خلاص fine. So again, according to those results, concentration 1, it required, the vitamin C, the DCPEP, it required 0.5 to change its color when concentration 1 was added. For 0.75 it shows, and J1, J2, and J3 also it shows the results. Now, if you come and estimate the vitamin C concentration in J1, you will find that there is 2 centimeter cubed of J1 was needed to decolorize the DCPEP, and it is just like the concentration 0.5, so you can estimate that J1 is 0.5. For J2, it is 1 centimeter cubed needed, so it is in between 1 and 0.75. So you can simply add them and divide them by 2, so you can estimate, or you get better estimation. For J3 it is 0.5, and which goes, it's going to be less than 0.125. So all of that is about estimation. Now there are several sources of error in this experiment. For example, misjudging color is one of the major sources of error. So when you stop adding is one of the sources of error. The second source of error, you might add more than needed. Yeah. Sometimes you add more drops than needed, because we are humans and we do mistakes. Drops might be, let's say, sometimes also stick to the glass. So there is another source of error. All of those are sources of error. To improve, you can use color meter for judging color. You can use a pipette instead of syringe to get more accurate estimation of volume or a more accurate measurement of the volume. All of those are basically improvement. Furthermore, having more or larger range of concentration of vitamin C concentration, larger range and smaller concentrations means smaller intervals. So guys, this is the end of this lab. Thank you very much and have a nice day.